Hi everyone, we are excited to present our group project on solving equation with elementary law operation ERO. And in this part, we will walk you through solving the system of equation. Our first equation is 3x minus 2y equal to x, and our second equation is 5x minus 4y equal to 13. We will use metric to solve this system by step, starting with setting up the augmented matrix and applying ERO theory and methodically. Let's begin.
We focus on column 1, which contains number 3 and number 5, and we need to change them into number 1 and 0. Now we focus on number 3, and we need to change the number 3 into 1 by using the formula R1 divided by 3. Each element in row 1 need to divide by 3. For column 1, row 1, the value is 3. Using formula, we divide 3 by 3, which equal to 1. Then, for column 2, row 1, the value is negative 2. Using formula, we divide negative 2 by 3, which equal negative 2 per 3. For column 3, row 1, the value is 8. Using formula, we divide 8 by 3, which equal 8 per 3. Last, we get the answer 1, negative 2 per 3, and 8 per 3 in row 1. But the most important is number 3 in column 1 change into 1. Next, we focus on number 5. We need to change number 5 into 0 by using formula R2 equal 5 times R1 minus R2. Each element in row 2 need to use this formula. For column 1, row 2, the value is 5. Using formula, we times 5 with 1 and minus 5, which equals 0. For column 2, row 2, the value is negative 4. Using formula, we times 5 with negative 2 per 3 and minus with negative 4. Then, for column 3, row 2, the value is 13. Using formula, we times 5 with 8 per 3 and minus with 13, which equal 1 per 3. Last, we get the answer 0, 2 per 3, and 1 per 3 in row 2. But the most important is we focus on change number 3 in column 1, row 2, into 0.
To get the answer for x and y, we will need to change the matrix into identity matrix. Therefore, we need to change the number of 2 over 3 to number 1. To get number 1, we can use row 2 divided by 2 over 3 equals to row 2. Because we know that every number divided by itself, we can get number 1. So, by using 2 over 3 divided by 2 over 3, we can get the answer 1. So, the calculation will also need to apply to everything in the same row. Therefore, number 1 over 3 divided by 2 over 3 will get the answer for 1 over 2. And this will be our current matrix. To get identity matrix, we will need to change negative 2 over 3 to 0. We can change it to 0 by using this rule, which is row 1 equals to row 2 times 2 over 3 plus row 1. A simple example, when 1 times with 1 plus negative 1 equals to 0. And then we'll substitute negative 2 over 3 into the row. And then we'll get the answer 0. So the same calculation will also need to apply to the number in the same row. So we'll substitute 8 over 3 into the row 2. And then we'll get the answer, which is 3. And this will be the final answer, since we already get identity matrix, where 3 actually represent the answer for x and 1 over 2 represent the answer for y. So our final answer for x will be 3 and y will be 1 over 2.
In just over a minute, we have shown how ERO gives us the solution. X equal to 3 and Y equal to 1 over 2. This method is systematic, organized, and works for largest system too. Thanks to my team for their work in preparing this presentation, and thank you for watching.